Namaste. Today we'll discuss about reciprocal function. Reciprocal function will be in the form of y equal to k upon x, where k is some real number. The graph formed by the reciprocal function will be in the form of hyperbola, rectangular hyperbola. Okay. Uh, See, aeroplane, it flies faster than sound. That's why we say it breaks the sound barrier. When it hits the ground, no, a hyperbola shape is formed. A sonic boom is also formed. Okay. At See, when the curve it touches each point of the curve at a time, all hear that sound. The sound comes from here itself, not from the outside. Okay. Now different types of reciprocal function and their nature we'll discuss. First thing is y is equal to 2 upon x minus 1. Here degree, I took this example to illustrate the degree of the denominator is more. In second case, both degree of numerator and denominators are same. In third case, degree of the numerator is less than the degree of the numerator. Y equal to 2 upon x minus 1. X-intercept we'll try to find. If you try to write y equal to 0, then you cannot write x-intercept. So there is no x-intercept here. When it comes to y-intercept, put x equal to 0, then y equal to 2 upon minus 1. So y equal to minus 2 is the x-intercept, y-intercept, sorry. Vertical asymptote. See, asymptote is a line where this function approaches but not reach or not intersect the line. Such line is called asymptotes. When y is not defined, then a vertical asymptote is formed. When y is not defined, that x minus 1 is 0. That means x equal to 1 is the vertical asymptote. And horizontal asymptote you see. Here the degree of the denominator is less, no? That time horizontal asymptote will be y equal to 0. That means x-axis itself. Okay. Next, what else we can talk about means we can talk about the critical point. Here x equal to 1 is the critical point. Here the graph is positive and here the graph is negative. After the critical point, it will be negative. We'll see in the Desmos. Y equal to 2 upon x minus 1. See here, y-intercept, you are going to see 0 minus 2. There is no x-intercept. And critical, and you can see that this vertical asymptote x equal to 1. This is a vertical asymptote. Here, see, it will look like that this curve intersect, but it won't touch. You can check at the far end also. Okay. See, and more we told this is critical point will be x equal to 1. Why here, see, when you are approaching from the right side of 1, okay, then it approaches to infinity. When you are approaching from left side, it approaches to minus infinity. Okay, we can tell the behavior of the curve also. Okay, next graph we will go. Next graph is this. We have to find x-intercept, put y equal to 0, then 4x minus 2 equal to 0. Okay, then x equal to half, I think. Plus 2 will go, 2 divided by 4, half we will get. X equal to half is the x-intercept. Y-intercept, put x equal to 0, minus 2 by 2, then y equal to 1 is the vertical. See, y-intercept. Next we'll come to vertical asymptote. Vertical asymptote means the denominator cannot be 0. That time only y is not defined. Okay. Then when it is possible, when x minus 2 is 0, that is x equal to 2 is the vertical asymptote. When it comes to horizontal asymptote, see, x should not be defined. When x is not defined, then only we can find horizontal asymptote. Okay. Here y equal to formula is there. Now we have to write x equal to formula. Then we can say when x is not defined. It is a long process. one shortcut is there. What you can do, no? Here degree is same, no? We have to divide the coefficients of the highest exponents, that is 4 upon 1. Y equal to 4 is the horizontal asymptote. Now we'll see the graphical calculator also. So here two critical points will be there. What are they means? Uh, one is 2, x equal to 2, that is vertical asymptote, and another is x-intercept half. Here it is positive, between 2 and half it is negative, and after less than half it will be positive only. Okay, we can see the graph behavior. Okay, you can remove this. It will give a confusion. Y equal to, and what is the asymptote? X equal to 2, no? See here, x equal to 2, and horizontal asymptote also is there. We told y equal to 4. That also you check. Horizontal asymptote came. See, this hyperbolas, rectangular hyperbola is formed. Okay, it is having both horizontal and vertical asymptotes. And to tell the nature, see, here see, first we told critical point is 2. When you are approaching from right side, it is positive. Okay, it takes all positive. Y is positive, see here. And between 2 and here, between 2 and the x-intercept half. Here the y values are negative, see, minus sign. After half, y values are positive. So this sign graph will tell the sign, see. It will decide the sign. And we can even tell the behavior of the curve when it approaches, when near asymptotes we can tell. Okay, when you are approaching 2, x values approaching 2 from left side. Okay, then what happens? 2 from left side means here. Okay, 2 from left side means f of x values approaches to minus infinity. And when you are approaching 2 from right side, y values approaches to plus infinity. Your horizontal asymptote is there. That time what happens, we'll see. When x is approaching to minus infinity, y is approaching to 4 left side. Okay. Similarly, when x is approaching to minus infinity, y is approaching to 4 from right side. Okay, right side, this side. Okay, this nature also we have discussed. One more last graph is there. Okay, last case. This, it is not available in any textbooks also. Okay, y equal to x square minus 1. Here see, what happens means, here degree of the denominator is less. Okay, that time what will happen, we will see. If you want to find x-intercept y equal to 0, you can keep, then x square minus 1 will be 0. That time x square minus 1 is 0 means two x-intercepts will be there. X equal to, this you can factorize using a square minus b square, and x square equal to plus 1 and minus 1. Two x-intercepts are there. And if you come to y-intercept, that means x equal to 0, then y equal to minus 1. Okay, one second. And y is not defined, see, 0, denominator we can't take, no. So y-intercept is not defined. Sorry. And vertical asymptote will come to now. Then denominator is 0, that is x equal to 0, that is y-axis is vertical asymptote. Horizontal asymptote, see. Here denominator power is less, no. Horizontal asymptote cannot be formed. So here also no. Here three critical points are there. Y means two x-intercepts are there. So minus 1, 0, minus 1 here we can write, sorry. First this will be positive. Between 1 and 0, all proper fractions, positive proper fraction, it is negative. For all negative proper fractions, it is positive, less than 1 minus sign. Okay, now we'll see the graph, then we'll come to know. Okay, this see, y equal to x square minus 1 upon x. Okay, y equal to x square minus 1 upon x. See that this y equal to 0, that means x equal to 0. Y axis is vertical asymptote, there is no horizontal asymptote. See, and based on the sign also you told up to 2 it is positive, y will be positive, and between proper fractions 0 and 1 it is negative, and all negative fractions that time it is approaching to minus infinity, it is positive. After minus 1, see, the curve is negative, no, minus sign. So from sign graph, what and all predictions we have done, that is correct. And we can tell the nature of the curve also. What happens when, okay, one here, see, uh, okay, here when you are approaching, here this is the curve, no? Vertical asymptote is this. Okay, when you are approaching to 1, what happens? F of x tends to infinity from right side. When you are approaching to 1 from right side, f of x approaches to plus infinity. Okay, between 0 and 1, minus infinity. Between minus 1 and 0, plus infinity. And after this, x values, when you are approaching to minus 1 from left side, then f of x is approaching to, y values are approaching to minus infinity. Okay, two intercepts are there. Okay, three critical points are there. 1, 0, and minus 1. So signs are changing like this. Okay, and behavior is like that. Okay, three different cases we have discussed today. More than x-intercept and y-intercept, finding asymptotes is a difficult part. Okay, and you have to remember, see, when degree of denominator is less than 0, y equal to 0. When both degrees are same, you have to divide the coefficients. When degree of denominator is less, we can't find the horizontal asymptote. Vertical asymptote, it is very easy. Every time you will make the denominator 0. When y is not defined, anyway you will be having formula y equal to formula like that you will be having. No, we can write vertical asymptote very easily. This and all hints you have to remember. Thanks for watching.